Hello dear students, again a very warm welcome to the physics classes. I am Abhishek Kumar Chowdary, physics lecturer with Sri Chaitanya. Our topic was nuclear physics, and in nuclear physics we have done the radioactivity, natural radioactivity in the previous class. Today in nuclear physics topic, what we are going to do, we are going to study the law, the mathematical interpretation of law of radioactive decay. This was the law, we can see, law of radioactive decay. This law was given by none other than Rutherford and Soddy. Rutherford and Soddy, they studied the rate of nuclear disintegration, how rapid was that or how slow was that, on what factor it used to depend. So let's start with the law. The law was the number of radioactive nuclei decaying per unit time. We are talking about the rate here. We can see the number of radioactive nuclei decaying per unit time. That means this is the rate with respect to time. At any instant is directly proportional to the number of nuclei present at that time. It means, suppose disintegration rate, radioactive nuclei being very unstable, is decaying to the stable nuclei that was called daughter nuclei. So that disintegration rate, how quick was that, is actually depends number of nuclei present at any time. Greater is the number of nuclei present, higher was the decaying rate. So the rate of decay is proportional to what? Depends on what? Radioactive nuclei present at that time. And on what factor it does not depend? It does not depend upon the external conditions. Doesn't matter what is the pressure outside, doesn't matter what is the temperature outside. The only factor on which the rate of disintegration of a radioactive nuclei depends is the number of nuclei present at that time. So mathematically, if you want to write this, we should write this like minus dN by dt is proportional to what? Proportional to n. This is the mathematical, or you can say the differential equation of the law of radioactive decay. Why the minus sign is here? Because we are talking about decay, disintegration. So negative is indicating disintegration. dN by dt is indicating this is radioactive decay, the rate, the rapidness of radioactive disintegration, and proportional to what? Number of radioactive nuclei that we can see here, number of radioactive nuclei n. Okay. Now one more important thing before deriving the actual equation, we can see after decay has happened. Now what is reached? The daughter nuclei, the stable one. After decay, the new nuclei has totally different physical and chemical properties. It means the parent nuclei, that is unstable, is being decayed to the daughter nuclei, that is stable, but they both are having a different set of physical and chemical properties. That's why the stability is also differing, isn't it there? One is unstable, one is stable. So why, if same properties were there, then stability will also be same. So you do remember the daughter nuclei is having the different set of physical and chemical properties as compared to the parent nuclei. Now get to the law. Minus dN by dt is proportional to n, the number of nuclei left. So can we write dN by dt is equal to lambda n, and shift the negative towards the right. The lambda is called decay constant. Lambda is called decay constant. Do remember, this decay constant is constant for a certain decay. For every decay, suppose there are 10 decays. So for every decay there is a constant lambda. One proper decay is with a proper constant lambda. Lambda is not Listen carefully students, lambda is not the universal constant, rather constant for one decay. Now we will establish the law of radioactive decay. Differential equation we got it, minus dn by dt is equal to lambda n, and what is lambda? Lambda is the decay constant. Fine, let's start with this. dn by dt is minus lambda n. So variable separable, dn and n in one side, one differential variable, dt is the second differential variable on other side, and let's integrate it. At t equal to 0, suppose the number of radioactive nuclei present was n0. What is n0? Number of nuclei at t equal to 0. Okay. So t is 0, the lower limit for dt, and lower limit for dn was n0. So let's start at t equal to 0, n equal to n0. After time t, when we are actually saying calculating the number of nuclei, so after time t, when we are calculating the number of nuclei, what we see? We see that n nuclei is there. Okay. Initially at t equal to 0, how many nuclei? N0. At t equal to t, how many nuclei? N. So these are the upper limit. dn by n integrating will give you logarithmic ln n by n0, upper limit by lower limit ln n by n0, and minus lambda dt's integration is t. So this we got in terms of log and time, this equation we got. Now if we will exclude this ln from the left hand side, ln means we are talking about the natural logarithm. Ln, what is ln? Ln is the log whose base is e, natural logarithm we are talking about. So when we will exclude this ln from the LHS, the RHS goes to the power of the base. And what is the base? Small e. So just spare the ln from the LHS, and the RHS will go to the power that was the e. So minus lambda t is power of e, and what is n? n0 e raised to power minus lambda t. And you have to actually think what is n? N is the number of nuclei left at that time. It is not the number of nuclei decayed. Do remember this. In this law, first of all, this law is exponential law that we can clearly see. And do remember what is n, what is n0, what is lambda, and what is t. N is the number of radioactive nuclei left at the time. N0 obviously was the initial, and the disintegration is exponential. Exponential decreasing. Do you know what is this exponential decreasing? That decreasing exponential means that is not going to saturate at a finite time. It is decreasing, 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 and keep on decreasing. At any finite time, you cannot get an infinite value, that is 10 is decreased to 2. This is not the case. N0 will keep on decreasing. That kind of decreasing is called exponential decreasing. Now we will see the graph related to this graph, and let me tell you students, graph from radioactivity is one of the most important question type in NEET. See, first we are drawing graph of what? Nx and t. Okay, Nx and t, and read here what is Nx? Number of nuclei left that was present at that time, that means n. So we can see the graph is what? Exponentially decreasing. This is the graph, and you can see this graph is going to saturate at infinity. How to get that? Can you see this graph is getting parallel to time axis, and you know that parallel lines will meet at infinity. So this exponential decrease is going to get saturated at infinity. It means never. There is no finite time. That's why it's called as exponential decrease. Now if you will draw a graph of number of nuclei decayed, not left, we are talking about decayed. So students, what was the initial one? Initial one was number of nuclei and not. Okay, and what is left? Left is n. And what is n? We have n as n naught e raised to power minus lambda t. So if you will put its value, n you will get at, we are talking about ny here, n naught minus n naught. What is n? N naught e raised to power minus lambda t. So this will be n naught 1 minus e raised to power minus lambda t. This is ny, and for this equation we draw graph like this. This is called exponentially increasing. Obviously, if the decaying, the number of nuclei left is decreased exponentially, so number of nuclei decayed will obviously increase exponentially. So these are the two graphs: exponential decrease for number of nuclei left and exponential increase for number of nuclei decayed. Suppose question is asking you the graph for log ln n. N is obviously the number of nuclei left. So we can draw an equation, because the graph in every, whether you are doing in kinematics or in thermodynamics or in nuclei, graph is plotted according to equation. Do remember this, graph is always plotted according to equation. So if we want to plot this graph with t, we have equation here, students, this, and that we can write as, let me write it for you, we can write as ln n minus ln n naught is equal to minus lambda t. So if this is y, on y axis you can see this is y axis, and if this is x axis, can you see equation like y equal to minus mx plus c, y equal to minus mx, m lambda is there, I am saying m for the slope, straight line standard equation, y is equal to minus mx plus c. So this graph is a straight line with the negative slope, and that line is this. So this is exponential decrease, this is exponential increase, and when the graph is asking you in terms of log, the graph is straight line with the negative slope. Okay. Now a similar topic related to this dn by dt, the law was dn by dt equal to minus lambda n, and that dn by dt is called, students, activity. So if question is writing a term of word as activity, you have to get it, activity is number of decays per unit time, or you can say the decay rate. And what was the decay rate? Decay rate was dn by dt. The rate of decay, how rapidly the nuclei was decaying, was dn by dt, and that dn by dt is called, students, activity. So this activity is what? You have to differentiate that, and this activity you know is lambda n. So can I write activity as lambda n? Yes, see, I am not writing lambda n naught, I am writing lambda n. And now we know that what is n? N is n naught e raised to power minus lambda t. So this lambda n naught can be termed as the initial activity r naught e raised to power minus lambda t. So the activity has got the similar formula, n equal to n naught e raised to power minus lambda t, and r, the activity dn by dt, is also r naught, the initial activity lambda n naught e raised to power minus lambda t. So the graph will also be similar, you can see, for n graph and for activity graph. One very important thing is there, the units of activity. Activity has got, you have to memorize, students, these units are very important, you have to keep on converging in numericals also. Unit is becquerel, Curie and Rutherford. Becquerel, the actual unit is dps, disintegration per second, dn by dt, but these three units are there which are related to dps, means disintegration per second. Becquerel actually he discovered the natural radioactivity that we are studying right now. So one unit is on the name of becquerel. Becquerel is 1 disintegration per second, 1 dn by dt is called becquerel. Now what is Rutherford? 10 raised to power 6 dps, 10 raised to power 6 becquerel is 1 Rutherford, and then 1 Curie. 1 Curie is 3.7 into 10 raised to power 10 disintegration per second. So this was the actual mathematical form of the law of radioactive decay, and let me repeat it for you, one of the most important topic from nuclei for NEET. Let's solve a problem on the law of radioactive decay And the question you can see it was asked in NEET 2017. Let's start with the question. Radioactive material A has a decay constant of 8 lambda, and material B is also there, has a decay constant of lambda. Fine. Initially they have same number of nuclei. So can we say N naught of A is equal to N naught of B is equal to N naught, since initial number of nuclei are same. So let's write like that. Okay. Now question is, after what time? From here question actually starts what they want to ask you. After what time the ratio of number of nuclei of B to that of A will be 1 by E? Means after what time NB upon NA is 1 by E. After what time? Do you have the equation? Yes, you have. NB is N naught E raised to power minus, what is the lambda for B? It was lambda T. T is the time after what time spent. The ratio we are discussing is 1 by A upon NA. N naught E raised to power what? Minus 8 lambda T is 1 by E. N naught cancelled, as initially were equal for A and for B, initial number of nuclei. Now to mathematically solve this, you can see E raised to power minus lambda, and this minus 8 lambda will go up, and what it will be? It will be 7 lambda T, and this will be equal to E raised to power minus 1. So from here we can write T is equal to minus 1 by 7 lambda. There was a mistake in NEET that they asked NB by NA. That's why it was a dicey question. They should have write NA by NB, then the question would have been right. So here time is coming at negative, but on the basis of 4 options given, you have to take 1 by 7 lambda. Suppose they would have asked NA by NB is 1 by NE, then we could easily find 1 by 7 lambda. It was a mistake, a slight mistake, but you can see this question was based on law of radioactive decay. Now we will discuss a very common but very important topic, half-life of a radioactive nuclei. See, what is half-life? First start with the definition. The time interval during which the number of radioactive sample falls half of its initial value. So the radioactive sample is decaying to get the stability. The time duration after which the half of the number have decayed. So what is left? Half is left, half is decayed, half is left. So see, first here N equal to N naught E raised to power minus lambda T, that you know, law of radioactive decay. What is N, students? Number of radioactive nuclei left. Okay. Now according to that definition of half-life, what we are saying? We are saying when N is equal to N naught by 2, half has been decayed, half is left. So obviously the left is N naught by 2. Then the time is called half-life. Put these two values, N equal to N naught by 2 and T equal to half-life, N naught cancelled. Taking log, ln, natural log both the sides, ln of 1 by 2, when we take ln in exponent, exponent becomes the coefficient, minus lambda T half ln E. And what is this ln E? This ln is 1. Also ln 1 by 2 can be written as negative of ln 2. That is negative of lambda T half, negative cancelled, and we have a formula for half-life ln 2 upon lambda, where you know that lambda is the decay constant. Ln 2 can be converted into a numerical value by log 10 base 2. The conversion is ln equal to 2.303 log 2. Log 2 values when you will put, what you will get? T half-life is 0.693 by lambda. This is the formula that we most frequently use. Half-life is 0.693 upon the decay constant. Now, some important point about half-life. What are the important points? First was here, students. Half-life varies from isotope to isotope. So, half-life is basically there defined for a certain decay. So, it varies from isotope to isotope. The next point is T half is a characteristic property. What does that mean? See the term characteristic property. It means half-life for a certain nuclei is constant and it cannot be changed from any known method. Suppose a certain nuclei has got a half-life of, suppose we say 10 raised to power minus 6 seconds. So, you cannot do anything to change that half-life. This is defined for a certain nuclei. It is a characteristic property of that nuclei. You can have a different half-life only when you are having a different nuclei. For one nuclei, half-life is constant. Now, parallel decays. See, first, what is parallel decay? When the decaying is taking place by many methods, like activity there R is R1 plus R2 plus R3. Activity is sum of all the activities. So, first decay is lambda 1 constant, second decay is having lambda 2 constant. So, many decays are there simultaneously. So, what is the net decay constant for parallel decays? When in question, it is given that there are two radioactive samples decaying with one lambda 1 and second lambda 2. Then what is the lambda? Lambda 1 plus lambda 2 plus lambda n, and lambda you can write ln 2 by T half, ln 2 will be cancelled. So, 1 by T half is 1 by T half of 1, 1 by T half of second, and so on. From here you can calculate the net half-life, and from you can calculate the net decay constant for obviously parallel decays we were talking about. This is an important one. You can see number of radioactive nuclei after n half-life. See, after n half-lives, it means after first half-life n naught by 2, after second half-life n naught by 2's half, that is n naught by 4, after third half-life then n naught by 4's half, n naught by 8. In that way, after small n half-lives, this is n naught divided by 2 raised to power n. This is a very important formula for objective questions. After n half-lives, what is the number of radioactive nuclei left? N naught upon 2 raised to power small n. And this is the graph n by n naught. You can see n by n naught, the fraction was 0.5 at the first half-life. So, after the second half-life, when 0.5 becomes 0.25, 2 half-life. So, this is decaying to half. Actually, what happens, let me tell you, for any fraction, if you are talking about, suppose a radioactive sample has having some mass and is decayed to some other mass, for that the time is constant. For any fraction, the time is constant. So, if that fraction is half, then that time is called half-life, but that time is constant for all the decaying fractions. So, that decaying fraction is half fraction has been decayed, then the time taken is called half-life. So, now we know what is half-life. The time taken for the radioactive nuclei to fall to its half value of the initial one. Now we will discuss, now we will see what is the mean life or what is the average life. That is our topic. See the definition, it is a total lifetime of all the nuclei, total lifetime of all the nuclei, dn into t summation, t into dn, the total lifetime of all the nuclei, summation we are adding t dn1, t2 dn2 and so on, divided by total number of original nuclei. So, total lifetime of all the nuclei divided by total number of nuclei, dimensionally also you can see d and n cancel, and summation of all the t is the average or mean life. Now, since this is differential, in place of summation we are writing integration 0 to infinity all the lifetime t dn upon n naught. But what is dn? dn by dt is minus lambda n, law of radioactive decay. dn by dt is minus lambda n. So what is dn, students? Minus lambda n dt. So in place of dn, minus lambda on dt. And what is n? N is n naught e raised to power minus lambda t, the exponential law. N is n naught e raised to power minus lambda t. So n naught cancelled, t lambda e raised to power minus lambda t dt is left, and after integrating it with a proper method of integration, we get that the tau that we started, the mean life, this is 1 by lambda. So tau is 1 by lambda. Reciprocal of the decay constant is called 1 by decay constant is called mean life or the average life. So how it is related to that? Related to that half-life, very easy conversion formula there. Half-life is 6.693 by lambda, means 1 by lambda there is what? Mean life. So this is 0.693 into the mean life. So mean life is t half upon 0.693, and this is 1.443 of t half. It is an easy conversion, but do remember that. One more interesting thing that you want to say is, you know n is equal to n naught e raised to power minus lambda t, but when I will put t is 1 mean life like this, when t is equal to 1 mean life. So one more interesting thing that you want to say is n equal to n naught e raised to power minus lambda t, and if the total time is the mean life, so this t become tau and lambda is already 1 by tau. So this is e raised to power minus 1, which is n naught by e, which is 0.37 n naught, or we can say the 37% of n naught. So isn't it a very nice definition? The total time, the average, the mean life is the time after which the nuclei reduced to 37% of the initial nuclei. So these were the data, these were the interesting topic that we discussed today. In next class, some more interesting topics, some problem applications of this topic that we have learned is yet to come. So do focus, do remember, do revise, do learn. Happy learning, stay happy, bye bye.